Introductions to solutions and aqueous reactions, predicting solubility. In this tutorial, we will be going over electrolytes, non-electrolytes, classifying chemical species as strong, weak, or non-electrolytes, dissociation equations, and predicting solubility. An electrolyte is defined as a substance that dissolves in water to form solutions that conduct electricity. The key things that we're looking for here when we talk about electrolytes is the ability to form ions. So examples of ionic solids could be something like sodium chloride or potassium nitrate or magnesium sulfate, all that can break down to form ions in solution. Strong acids are also a type of electrolyte. Examples might be hydrochloric acid, nitric acid, or sulfuric acid. All of these will ionize to form hydrogen ions and their associated negative ion. Weak acids have the ability to ionize slightly, and we'll talk more about that in future chapters. Acids like acetic acid, sulfurous acid, or nitrous acid. Strong bases are also electrolytes. Examples are sodium hydroxide, potassium hydroxide, calcium hydroxide, where all of these compounds will break down into positive and negative ions in water. Examples of weak bases are ammonia, sodium carbonate, and methylamine. All of these compounds, when dissolved in water, will conduct electricity slightly. Let's talk about the definition of dissociation. Dissociation is the process in which compounds separate or split into smaller particles such as atoms and ions. An example of dissociation is potassium permanganate dissolving in water. So we could have the formula KMNO4 as a solid, dissolving it in water. So I'm going to draw my arrow and then water over the top of it to form potassium ions, obviously aqueous, and permanganate ions, MnO4 minus 1 AQ. Throw an A in front of there. So AQ. The key thing about dissociation is that compounds like potassium permanganate are ionic compounds, so in a crystalline structure, they're still considered ions that are held together by strong electric forces of attraction. This differs from ionization. In ionization, this is the process by which an atom or a molecule acquires a negative or a positive charge by gaining or losing electrons. Ionization can also be defined as when a molecular substance, such as an acid, dissolves in water to form ions, such as a hydrogen ion and an anion. An example of this might be when perchloric acid, so HClO4, breaks down in water to fully ionize. So again, we have water, breaks down in water to form hydrogen ions, and the perchlorate ion. Strong electrolyte. A strong electrolyte is a substance that completely dissociates into ions when dissolved in water. We can use the example of magnesium nitrate. So MgNO3, 2, when added to water, put water over the top of this, will form magnesium ions, Mg plus 2 aqueous plus nitrate ions, and in this case 2NO3 minus 1. A strong electrolyte is any soluble ionic compound or any strong acid or base. A weak electrolyte is a substance that does not completely ionize in water and only weakly conducts electricity in solution. Solutes that exist in solutions mostly in the form of molecules with only a small fraction in the form of an ion. An example here is acetic acid. So the formula for acetic acid is HC2H3O2, and when that is dissolved in water, it will only slightly ionize. which means it will form some hydrogen ions and it will form some acetate ions. So C2H3O2 minus 1. But the majority of the molecules in solution will remain as HC2H3O2, and only some hydrogen ions and only some acetate ions will form. That is why we have this reversible arrow right here to say, hey, it can go back and forth. But when we learn more about acid-base equilibrium, we will find that most of the time, equilibrium is going to lie to the left in the form of HC2H3O2. A non-electrolyte. What is a non-electrolyte? A non-electrolyte is a substance that does not dissolve in water to form solutions that conduct electricity. So an example could be sucrose, which is C12H22O11. When that is dissolved in water, the intermolecular forces that hold the sucrose molecule together, those will break, but the sucrose molecule itself will not. But no covalent bonds are broken as sucrose dissolves in water, otherwise known, of course, as table sugar. So if we look at this clip from this PhET simulation, we can see this conductivity tester being placed in the water, and we can see that the light bulb is not turning on. But when sugar is added, the light bulb continues to not go on. So that means that no ions are being formed, no charged particles. So the sucrose remains neutral when it dissolves in water and intermolecular forces are broken between the molecules. Classifying chemical species as strong, weak, or non-electrolytes. So if we look at our first example, C2H5OH. If you recognize this, you will know that this is a non-electrolyte. Specifically, if you've taken organic chemistry, you know that this is ethanol because we see this alcohol group. This is not hydroxide. When we look at the structure here, we can see that this alcohol group, this OH, is attached to this carbon right here. There's not a big enough difference in electronegativity values between the carbon and the oxygen for this to ionize and form a hydroxide ion and the remainder of the alkyl group. So because we look at this and we realize that this is a covalent bond between the oxygen and the carbon, this will not form ions, and therefore it's a non-electrolyte. It's not going to form ions in solution. BaOH2 is a strong electrolyte, and it's a strong electrolyte because it's barium hydroxide. And we know that barium hydroxide is a strong base because it's going to dissociate into barium ions and hydroxide ions. HCl is also a strong electrolyte. That's hydrochloric acid, and it is a strong acid as it's going to fully ionize into hydrogen ions and chloride ions. NH3 is a weak electrolyte. This is ammonia, and it is a weak base. CH3COOH is an organic acid. It is a weak electrolyte, so it is ethanoic acid and is a weak acid. Write dissociation equations for the following chemical species when they are dissolved in water. Let's look at the first one, CaNO3 We know that this is a strong electrolyte because any compound containing nitrate can easily dissolve in water. So when we write the dissociation equation for this, we're going to recopy the CaNO3, going to draw an arrow, and then we're going to break it down into individual positive ions and negative ions. So Ca plus 2 plus 2NO3 minus 1. Because when we look at this formula, the ratio of our calcium ions to our nitrate ions are 1 to 2. So we need to have that 2 in front of the NO3 minus 1. SrBr2 is also a strong electrolyte. So we'll recopy that, SrBr2. That will break down into a strontium ion, Sr plus 2, and 2 bromine ions, 2Br minus 1. NH4Cl is also a strong electrolyte. because the ammonium ion is very soluble in water. So we're going to recopy NH4Cl. It's a sad looking 4. And that is going to break down into the ammonium ion, NH4 plus 1, and the chloride ion, Cl minus 1. And we don't need any coefficients in front because the ratio of positive to negative ions is 1 to 1. Na2CO3 is also a strong electrolyte. So we're going to rewrite this as Na2CO3. We know this is a strong electrolyte because it contains sodium, which is a group 1 metal, and therefore very soluble. The ratio of sodium to carbonate ions here is 2 to 1. So I'm going to write 2Na plus 1 plus CO3 minus 2. So a 1 to 2 ratio between sodium and carbonate ions. The next one is K2SO4, also a strong electrolyte. So we're going to write K2SO4 with an arrow. Like our previous example, this is also a 2 to 1 ratio between positive and negative ions. So I'm going to write 2K plus 1 plus SO4 minus 2. And then for the last one, Na3PO4, one more time, strong electrolyte. So we have Na3PO4. Now this is a 3 to 1 ratio between positive and negative ions. So for every 3 moles of Na plus 1, we will have 1 mole of PO4 minus 3. Predicting solubility. Solubility is defined as the amount of a substance that will dissolve in a given amount of solvent at a given temperature. A precipitate is a solid, insoluble ionic compound that forms in and separates from a solution. A precipitation reaction is a reaction in which a solid, insoluble product forms when 2 solutions are mixed. Predicting solubility. Write the chemical formula and predict the solubility of the following compounds in water. Refer to rules for solubility if necessary. So the first thing that we need to do is write our chemical formula. Lithium sulfate. Well, if we look at lithium sulfate, we know that our positive ion will be Li plus 1, our negative ion will be SO4 minus 2, and if we cross down our 2 and our 1, remembering no positives, no negatives, no 1s, the formula that we're going to have is Li2SO4. Knowing that all group 1 metals are soluble in water, that means that this is going to be obviously soluble. Magnesium hydroxide. Our positive ion is going to be Mg plus 2. Hydroxide is going to be OH minus 1. We're going to cross these down and get Mg parentheses OH n parentheses 2. And if you remember your solubility rules, you know that this particular compound in water will be insoluble. Cesium chromate. Our positive ion will be Cs plus 1. Chromate is CrO4 minus 2. When we cross these down, we get the formula Cs2CrO4. And again, we have a group 1 metal, so that means that this compound will be soluble in water. Finally, dimercury 1 bromide. Now, dimercury is a weird little polyatomic. Dimercury is Hg2 plus 2. Now, this 1 here comes from the bond between the 2 mercury atoms. So that 1 is really plus 1 for each mercury. So don't get thrown off by that. It's a little weird. So the positive ion is Hg2 plus 2, which is a polyatomic. The negative ion is going to be Br minus 1. So our chemical formula is going to be Hg2Br2. Now, don't reduce that. That will not be good because you won't have that polyatomic anymore. Is it soluble or insoluble? If you said insoluble, you are correct. So what did you learn? We talked about the definition of an electrolyte. We looked at non-electrolytes. We classified chemical species as strong, weak, or non-electrolytes. We did some examples with dissociation equations, and then finally we did a little bit of predicting solubility. Need more help? Feel free to contact me. Have a great day.